Yes. When you give.
Ma'am, I submitted today, ma'am.
No, we have to give only different question paper. Same question paper cannot be given. So you give me a time and a date when I can give you one. Maybe tomorrow? Hmm?
Yes, ma'am.
Hmm.
Yes.
Okay. So just give me a message or a WhatsApp message by today evening. What time tomorrow? Okay.
Okay, ma'am.
Thank you. Right. We were dealing with something called as transportation problem. I hope so. Everybody remembers what we were doing. We did northwest corner rule. After doing northwest corner rule, what we did? We did least cost method. After doing least cost method, we did Vogel's approximation method or VAM. Right. Now, what our solution we found out? It was basic feasible solution. But was the solution an optimal solution? We did not check for optimality. So now how to check for optimality? To check for optimality, we use something called as MODI method or modified distribution method. Okay, we check for optimality using MODI method. We use MODI method or modified distribution method. Okay, so now what is this that you have to know? You have to know two things. What is an independent position and what is not an independent position, that is non-independent position in a given table. So take down note. We are starting the class with the note. So instead of note, you can say even definition. Definition. The allocations are said to be in independent positions. The allocations are said to be in independent position. Okay. The allocations are said to be in independent positions if it is impossible if it is impossible if it is impossible to increase or decrease any allocation, increase or decrease any allocation without either changing the position of the allocation, without either changing the position of the allocation or or violating or violating the rim requirements or violating the rim requirements. Okay, this is the definition for independent position. You take down the definition, then I will explain by means of diagrams. Next, number 2. For allocations in independent positions, it is impossible to travel from any allocation back to itself by a series of horizontal for allocations in independent positions, it is impossible to travel from any allocation. It is impossible to travel from any allocation back to itself by a series of horizontal and vertical jumps. Horizontal and vertical jumps. I'll tell you what it means. Horizontal and vertical jumps. From one occupied cell, horizontal and vertical jumps from one occupied cell to another, from one occupied cell to another without direct reversal, without direct reversal of the root. Without direct reversal of the root. So this is what you mean by saying what independent position and how to identify the independent position. Now writing like this in pages together does not make much of a sense. Let us see how you can actually visualize this. Suppose see, I am going to have a grid like this. Normally transportation problem, it could be 3 cross 3, 3 cross 4, anything. So we are going to have a 3 cross 4 grid. Suppose we have an allocation here, we have an allocation here, we have an allocation here, and we have an allocation here. Now I can use only horizontal and vertical lines. I should be able to move from one allocation to the other. Now this particular point which I put tick mark, from here to here, it is not possible, isn't it? See, from here I can go there, then I can come to this side, I can come down. But how about these two positions? I can only go diagonally, I cannot go horizontal. Therefore, we say they are independent positions. That is why we call them as independent positions. Say suppose we can take another grid. Let me say we are going to have a 4 cross 4 grid. Now see, also all these lines, you cannot move from one point to another only by means of horizontal or vertical lines. So these are also independent positions. Now suppose you want to say non-independent position. How will you go for non-independent position? You should be able to travel from one allocated cell to another by means of horizontal and vertical lines. So let us look for an example like that. So let me choose a grid, some grid of our choice. So we can have say 5. Okay, so we are going to have a 5 cross 5 grid. I'm going to have allocations. Okay, so now see what happens. We can even do one more thing. Just a minute. Right. Now look at these allocations. From this point, I can go to this point. From here, I come down vertically. From here, I go here vertically. From here, again, I go vertically. Again, I go vertically like this, like this. So from one point to another, I am able to traverse only by means of horizontal and vertical lines. Therefore, it denotes non-independent position. Okay. So this is an example of a non-independent position. Very simple example. You can have a square or a rectangle. Done. Non-independent position. We have one point here, one point here. Very simple example they want to give you or identify would be normally this. So these are all non-independent positions normally which you come across in any problem. Okay, right. So now we know what is an independent position, what is a non-independent position. Based on this occupation only, we are going to go into finding out whether our solution is an optimal one or not. How to find out whether it is an optimal solution? We are going to use a method known as modified distribution method. We are going to use a method known as modified distribution method. Okay, so modified distribution method, normally in short form, is MODI method. This is very famous and is very useful for us also. Right. So I will give you the notes for doing stepwise how to find out this. So for problem solving purpose, what are the steps you need under this modified distribution method that you should remember? That alone I will put precisely. With that we will start the solution. Okay. Right. So now what you will do is first I have to find my initial BFS. That is basic feasible solution. First I will find my initial BFS. After finding my initial BSF, I have to check whether m plus n minus 1 equal to number of allocations. If true, okay, if true, then there is no degeneracy. Then there is no degeneracy. Otherwise, I have to resolve. There is no degeneracy. Go to 3. Okay, go to step. Now, if m plus n minus 1 is greater than the number of allocations. If it's greater than that, that is, it is not equal to the number of allocations. Rather, to be very precise, it's not equal to the number of allocations. Then resolve the degeneracy. Then I have to resolve the degeneracy. How to resolve the degeneracy? That is the next thing. What I will do is, I will introduce some epsilon, that is some artificial number, epsilon in one of the cells. In one of the cells. In one of the unoccupied cells. In one of the unoccupied cells. In where should I put this epsilon? In an unoccupied cell. In the independent position. Unoccupied cells in the independent position. So after I do this, it will become non-degenerate. After I do this, it will become non-degenerate. So I have to put this unoccupied cells in the independent position. So degeneracy resolved. So degeneracy resolved. Okay, and this will not take us 3. Next only we should take as 3. To do 3, check optimality. We will check optimality. In that one precise thing what I have to check is, I will give you only the main key inputs. Later on we will check everything. Okay, you have to check is Cij equal to Ui plus Vj. This we have to find out for occupied cells. This we have to find out for occupied cells. Then I have to find out Dij equal to Cij minus Ui plus Vj for unoccupied cells. Okay, this I have to find out for unoccupied cells. Then comes the question of me checking whether the solution is optimum or not. If Dij is strictly greater than 0, if Dij is strictly greater than 0 for all Okay, for all I comma j, then its solution is optimal and unique. Then the solution is optimal and unique. So this is the first thing. Suppose some dij is 0. So suppose my dij is greater than equal to 0, then the solution is optimal, but alternate solution exists. But alternate solution will exist. Alternate solution exists. Then, what is the third case that is feasible? It can be negative. So, if at least one dij is less than 0, the solution is not optimal. If it is less than 0, then the solution is not optimal. So these are the main things which we want to give. Suppose it is not optimal. Then what is the step number here? 3. Okay, so I have to go for the fourth step. If 3 is true, if 3 is true, then form a new BFS. Form a new BFS. Form a new basic feasible solution. So how to form this basic feasible solution? How to go about this solution? All that is there in the notes. I will put this up in the GCR for you. Okay, I will scan and I will put it up in the GCR for you. So today's class, you should know what is UI, what is VJ, how to find out CIJ, how to find out DIJ, and we should learn to check for optimality. That is our basic idea. Right. So I will take a small problem. Okay, using this problem, we want to check for optimality. Right. When we are doing this optimality check itself, I will also teach you how to resolve degeneracy. So take up. Solve the following transportation problem. Okay, to find the minimum transportation cost. To find the minimum transportation cost. Here it is source. On top it is destination. It is a 3 cross 3 problem. So you have 3 rows and 3 columns. In the base, what will you have here? Supply or demand? What are you going to have in the base? Demand. Yes. Here you will have demand. And on top, you will have supply. Let us fill the cells. You have 2, 3. Then I have 4. I have 1. I have 2. Then I have 1, 3. And I have 1. In the base, I am having 20. I have 15. I have 30. Then I have 10. I have 15. I have 40. First thing what I should do, I should check whether demand equal to supply. So let us check whether demand equal to supply. Is the demand equal to supply? Yes. So check your total now. 40 plus 15, 55 plus 10, 65. Here 30 plus 15, 45 plus 20, 65. Therefore, it is a balanced transportation problem. Therefore, sigma AI equal to sigma Bj. Therefore, it is a balanced transportation problem. Hence, we can start with the solution. Initially, what we should do? We should apply VAM. So, in order to apply my VAM, so what I should do? I should take the smallest number and the next smallest number in each column and subtract. So 1 and 2, 2 minus 1 is 1, 1 and 2, 2 minus 1 is 1, 1 and 2, 2 minus 1 is 1. Then here, smallest and the next is smallest, so value is 1, 1 and 2, value is 1. And here what do you have? 3 minus 1, value is 2. So, what should I do? Check here. Am I correct? Am I correct in what I did, or am I not correct in what I did? Yes, I should take the smallest and once again the next is smallest. So normally when we proceed like this, what we can happen is you have two twos and you have two ones. So these positions will become, here you can put 0, here also you can put 0. There will be absolutely no problem. Even if you make a slight change, nothing will go wrong. So 2 is the smallest. What is the next to smallest? That is also 2 for us. So 2 minus 2 is 0 and 1 minus 1 is also 0. Now what is this? Everywhere it is 1. It's a type. It is your choice. So let me choose this one. I have denoted the 1 by a tick mark. Now how much? I have to choose the least cost cell in this second row. Value is 1. Cost is 15 and 15. Allocate 15 for this cell. Once I allocate 15 for this cell, what happens? This supply gets tallied, so this row gets chucked. This demand also gets tallied, so this column also gets chucked. So now we are allocated 15. Next, what else I have to do? Here I have to put a dash, and here it is 3 minus 2, value is 1. Here it is 1 minus 1, value is 0. Here it is 2 minus 1, value is 1. Here it is 3 minus 1, value is 2. Select the maximum. Maximum value is 2. Now look at this column. Choose the cell with the least cost, that is 1. How much you can allocate? 30 or 40. So I allocate 30. The minute I allocate 30, what happens? This demand gets satisfied. Now, what should I do? Now what should I do? I have to put a dash here, I have to put a dash here. Here the value is going to be 1 for me. And here I need not calculate, rather I have only two entries, 2 and 1. So for 1 I can allocate 20 or 40. So already I have allocated 30. Therefore of 40, 30 is gone. See, of the 40 supply, 30 is gone. The remaining value is only 10. Similarly, to the top 20 I have given 10 in the demand, remaining is 10. Now check if you have satisfied everything. 10 plus 10, 20, here it is 10. So this row is also satisfied, this column is also satisfied. 20 plus 30 is 40. So this row is also satisfied. Hence what happens? All our allocations are properly satisfied. Yes. Now we have to check for degeneracy. How are we going to check? We have to check the number of allocations. Number of allocations is how much, ma? Number of allocation is how much? Huh? Number of allocations means in how many cells have you allotted values? How many? You have denoted it within a T bracket, Mari. Yeah? You have denoted it within brackets. How many allocations? 2 tens, 115, 130. So there are only 4 allocations. So number of allocations equal to 4. Then what happens? My m plus n minus 1 is 3 plus 3 minus 1 equal to 5. Therefore, degeneracy occurs. Therefore, degeneracy occurs. So, what we have to do in the second step, this is the first step. We found out degeneracy is occurring. Okay, so this is my step number 1 for the problem. So, in the next step, what should I do? I I should resolve this degeneracy. So how to resolve the degeneracy? I should introduce a component epsilon in one of the cells in the independent position. Independent position means you should not be able to form a loop. Okay. So let us try it out. I will take a new sheet so that we can go ahead with it. So we are having a 3 cross 3. We are having a 3 cross 3. Entries are 2 to 3. 2, 2, 3, 4, 1, 2, 1, 3, 1. My allocation was I had 10 allocated here. I had 30 allocated here. The total was 40. Then I had a 15 allocated over here. I had a 10 allocated over here. So here it is 20, here it is 15, and here it is going to be 30. Okay, so now everything is tallying. Here it is going to be 10, here it is going to be 15, and here it is going to be 40. Yes. So everything gets tallied. Now we don't need the allocations right now in this table. So we will remove this portion so that we don't get confused. Now what we have to do is, we have to resolve the degeneracy. How to resolve degeneracy? You should put epsilon in an independent position. That means whereby you should not be able to form a loop. Okay. And it should be the minimum cost as far as possible. What are the unoccupied cells? First row, second cell, first row, third cell. Okay. 1 minute, yeah. Okay, now the cells are first row, second cell, first row, third cell. Similarly, second row, first cell, second row, third cell. Similarly, third row, second cell. So the minimum value that is there is 4, 2, 3. Minimum is 2. Either you can choose this 2 or you can choose the other 2. It is your choice. I am choosing this 2. Okay, if anybody wants to choose this other 2, go ahead, no problem. 2 is minimum. I have allocated an epsilon to this cell. So let me write a comment. Allocate epsilon to x12, that is minimum cost unoccupied cell, okay, unoccupied cell in the independent position, unoccupied cell in the independent position. So I have allocated. Now what happens? Therefore, number of allocations, what can I say? Therefore, number of allocations equal to, therefore, number of allocations is equal to m plus n minus 1 equal to 5. So, degeneracy resolved. This is what we have to do first. So, we have resolved the degeneracy. Hence, the degeneracy is resolved. Now, what I have to do in this case? I have to calculate my Cij and at the same time, I have to calculate my Dij. That is the next step. So, let us go on to step 3. So, in step 3, can I rub this? Allocate epsilon to x12. Can I rub this here? What? Otherwise, I have to redraw the table. That's all. So it's only a 3 cross 3 table. It will take only seconds for us to draw. So we are going to have the entry as 2 to 3. We are going to have 4, 1, 2. I'm going to have 1, 3, 1. My allocations are going to be 10, 30, and I have another 10. I have a 15. I have an epsilon. So now I have to go for the next step. That is step 3. What is my step 3 going to do? Calculate To calculate Cij equal to Ui plus Vj for what? All occupied cells. For all occupied cells. So how am I going to do this? Now look at this. What I will do is, to the side here, I will write U1, U2, U3. On top, I will write V1, V2, V3. I have to see only occupied cell. So the first cell is occupied. Cost is 2. So 2 is equal to U1 plus V1. Then first row, second cell. Yes, epsilon, it is occupied. So 2 is equal to U1 plus V2. Then second row, middle, third one. So value is 1. 1 is equal to U2 plus V2. Then third row, first cell. 1 is equal to U3 plus V1. Then third row, that last cell, 1 is equal to U3 plus I will have my V3. Now look at this. I have 1, 2, 3, 4, 5. 5 equations in how many unknowns? 6 unknowns. U1, U2, U3, V1, V2, V3. So I should put any one value equal to 0. What to put as 0? You should choose the variable which occurs maximum number of times to be 0. Now you can ask, what yeah? U1 is occurring twice, V2 is occurring twice, V1 is also occurring twice, U3 is occurring twice. Yes, your choice. The one which occurs most you can choose. It is your choice to choose one variable which occurring maximum number of times to be put as 0. For simplicity case, let us put U1 equal to 0. So I'm going to put U1 is 0. What happens if I put U1 is 0? I will have V1 is 2. Also, I will have my V2 value to be 2. Then substitute the V2 value in the third equation in this position. V2 is 2, U2 is minus 1. Come for the next one. V1 is 2, U3 is minus 1. If U3 is minus 1, what happens to V3? V3 takes the value 2. So this is the value that we are getting for U1, U2, U3 and V1, V2, V3. Once we are done with this, what should we do next? We must find step 4, Dij. How to find Dij? Step 4, we will write in this place itself. I have to find Dij equal to Cij minus Ui plus Vj for all unoccupied cell. In the first case, occupied means next is all unoccupied. So, for all unoccupied cells. So, how do you proceed? Yeah. What is the first unoccupied cell? First row, third cell. So, D13. My D13 is C13 minus U1 plus V3. Come on. What is C13? 3. The cost of the cell. Minus. What is our U1? 0. V3 is 2. So 0 plus 2. 3 minus 2 is 1. What is greater than 0? True. Then come for the second row. D21. There is no allocation. D21 will be C21 minus U2 plus V1. What is the C21? 4 minus U2 is what? Minus 1 plus what is our V1? 2. So this value is 3. So we are through. That's also greater than 0. Then D23. What is D23? C23 minus U2 plus V3. What is C23? Yeah? What is C23? I want somebody to give me answer. What is C23?
One.
Ah, one now.
One.
I commit suicide now. What is C2? 3. Second row, third element. 2. 2 minus, what will I have inside? What will I have inside this bracket? What? Ah, yes. Minus 1 plus 2 value will become 1. So D to 3 is also positive, value is 1. That's what I got first as answer itself, I believe. Then I have to find D3 too. So directly shall we write D3 too? This is third row, second element, 3 minus U3 V2. U3 is minus 1, V2 is 2, which is equal to 2. Therefore, what happens? All my Dij are strictly greater than 0. Am I correct? It's 1, 3, 1 and 2. Therefore, all my Dij are strictly greater than 0. Since everything is greater than 0, what can I say about the solution? Step 5. Since everything is greater than 0, what can I say? Yes. Since all Dij strictly greater than 0, the solution is optimal, basic feasible solution, which is unique. Now we have to give the answer. What answer we have to give? Total minimization cost. Before writing total minimization cost, we should write optimum allocation schedule. That is your answer. The optimum allocation schedule. The optimum allocation schedule is equal to, or will not use equal to also, we can say is, where all you have allocations, yeah, x11. What is that value of x11? I think it is 10. Then I have x12. X12, what is that value? Epsilon. X22. Uh, X22, I think we allocated 15. Then X31, what we have? 10 and 30. X31 is 10 and X33 is 30. Therefore, the optimum transportation cost, therefore, the optimum transportation cost okay, optimum transportation cost is equal to, what will happen? 10 into 2 plus, I will have 2 into epsilon plus, I will have 15 into 1, am I correct? Plus, I will have 10 into 1 plus, I will have 10 into 1. So 10, 10, 20, 20, 20, 40, 40 plus 15. Check here whether I am correct. X33 is 30. So this would be 30. So this will also be 30. Right. So 20, 30, 50, 15, 10, 75. So this is going to be rupees 75 as epsilon is very negligible and tends to 0. Okay. So our optimum transportation cost is 75. Optimum allocation schedule is this. Okay. Now you can ask me, hey, you have taken one problem for 40 minutes. Then what the hell you are going to ask for 3 marks in this question? It seems to go into pages. It's not like that. What we will do is, I will give you this allocation. I will say calculate Cij equal to Ui plus Vj for all occupied cells taking U1 equal to 0. This alone can be asked for 3 marks. You are going to do only this much. We are going to solve only small, chota 6 equations. Done. Same way, I will give you the ui values and the vi values, and I will give you the table and ask you to calculate dij alone. That can come for 3 marks. Similarly, I will give the table, that is this table allocation alone I will give. Now all these things will not be there, only the table with the allocation, and then say, assuming the solution to be optimal, find the optimum transportation cost. So this calculation alone you should do. Probable 2 marker, or give the allocation schedule and the cost 3 marker. So this is how, even though the questions seem to be very lengthy in operations research, there are many ways of asking. Or I will do one more thing. I will give you all the UI values, ask you to justify Dij. Then Dij is unique solution, not optimal, optimal and unique, not optimal but unique, optimal with many. Then you have to compute all this Dij and give me the answer. That is another way of asking a 3 marker. So you see one question today we have done 5 3-mark questions. And giving the allocation and finding out, that is 1 3 marks. So 6 to 7 3-mark questions you are learning in one problem. So that is only beauty of one. However we want, we can ask you. Right. So now I'll give you one small definition, after which I'll take attendance. Okay. So take a unbalanced transportation problem. I'll just give you the definition. Problem we can do only in next class because it will still take the same amount of time. Unbalanced transportation problem. The given transportation problem is unbalanced if summation ai is not equal to summation bj. Then how do we solve this? Convert it into a balanced transportation problem. Convert it into a balanced transportation problem by introducing a dummy source, by introducing a dummy source or a dummy destination. By introducing a dummy source or a dummy destination. So this is what is done. With zero cost vector, I'll tell you what this is. With zero cost vector. Now I'll give you a very small example and finish off in just 1 minute and then take attendance and leave you. Let us now consider a very small example. Let me say I'm going to have a 2 cross 3 problem. Okay, I have source, I have destination. I have my 1, 2, 1, 3, 4, 5. I have the cost as 5, 1, 2. I have 2 and now you see, here you have 5 plus 1, 6 plus 2 is 8. Here you have 2 plus 2 is 4. Therefore, it is unbalanced. So, what is missing? My 8 minus 4, this another value of 4 is missing. Where should I get it? Under my, what is this? Supply. Under my supply, I should have. So, I will convert this problem into a 3 cross 3 problem. What I will do? Simply, I will copy the sum 1 to 1, 5, 4, 3. Put zeros in the extra row that I have introduced. In the base, I will write 5, 1, 2. Take the maximum of the total. Value is 8. So, here I have 2. I will copy the 2. Here also, I will copy the 2. So, what is remaining? 8 minus 4 is 4. Put the 4 next to the row of zeros. Now, this problem which is unbalanced earlier has now been converted into a balanced transportation problem. Suppose the deficiency occurs in the what? Demand. Then you will add a column. Here it is in the supply, so you have added a additional row. So this is how you pattern, and then you make an unbalanced transportation problem into a balanced transportation problem. Okay, so let us take